So, José, uh, it's yours. Welcome. Thank you very much. And thank you for your support. We are taking care of those things, and let's take a look at what was it. Okay?
Hello, good morning. Thank you, Claude, for the introduction. Thank you, Paulo. Thank you for inviting me to be here today for this presentation. It's my pleasure to be here to present some ideas, to share some concepts, and to talk about the projects that we have been developing at the Research and Development Department at the Embraer. So thank you very much for your invitation. The title of my presentation today is Innovation and Projects Developed in the Intelligence Systems Department at Embraer. This is the outline of my presentation. I will talk about the innovation process at Embraer, the technological development department, and finally, you will present some projects that we have been developing in the intelligence systems area at Embraer. Well, I will talk a little bit about Embraer and show to you the projects and the developments that we have been developing in the last 20 years. So, first of all, I would like to say that Embraer is one of the largest aerospace conglomerates in the world. It's a leader in the market segments in which it operates. Embraer today is the third largest commercial jets manufacturer in the world. The history of Embraer starts in 1946 when Brazil launches a national strategic aerospace initiative via the Aeronautics Technical Center, CTA, and the Technological Institute of Aeronautics, ITA. So we can say that the history of Embraer started 20 years before the foundation of the company. when the government launches the initiative in the CTA. Because for Embraer to be created, it was necessary to have good people with knowledge and competence to develop the products of the company. So the initial initiative, the first initiative was to develop, to create the Institute of Technologies to form, to have people qualified to develop the projects in the company. And in 1969, the federal government creates Embraer to develop and manufacture aircraft in Brazil. Another important mark in our history was in 1994, when Embraer was privatized, fusing technological and industry expertise with an entrepreneurial approach. And now, in 2023, Embraer is one of the world's leading manufacturers of commercial and executive jets, with substantial operations in defense and security. In this picture, you can see a lot of products and technologies that Embraer developed in the last 20 years. So we can see that we developed a lot of technologies and products in the last 20 years. But our development is not restricted to development of aircraft, airplanes. We have other companies, affiliated companies like Visiona, that produces and develop satellites. ATEC, that is a company that develops the air traffic management systems that is being used in Brazil. And we can see a lot of aircraft here, starting with the ERJ-145 until today, when you have the Praetor 500. Another important product that I can show to you, we have a company that produces radars, like the Sentir M20 and the Saber M60 that is being used in CISFROM. That's a program for the surveillance of the Brazilian borders. So we have these radars produced by Embraer and provided to the Army, Brazilian Army. We have military aircraft as well, like the early warning provided to me for the surveillance of the airspace in India. The KC-390 that's being delivered to a lot of countries in the world. So we have a large portfolio, as you can see here. And we're very proud about this technology and developments that we made in the last 20 years in the company. Some numbers about Embraer. We have more than 3,500 engineers working in the company. We are present in more than 100 countries. We have more than 20 certified aircraft using state-of-the-art technology. More than 145 million passengers are transported in Embraer aircraft per year. We have more than 8,000 aircraft delivered since the foundation of the company. And every 10 seconds, an Embraer plane takes off in some airport in the world. Today we have about 20,000 employees across the globe. An interesting number here is that we have 1,300 people with master degrees, PhD, and postgraduate people in the company. We have more than 5,900 people dedicated to research and development in the company, and more than 300 engineers dedicated to research and technology in the company. Here, in this graph, you can see that innovation is very, very important to Embraer. We can see that around 50% of the revenue from Embraer came from products and services that were launched until 5 years earlier. So innovation is not a choice or an option for Embraer. It's unnecessary for the future of the company. Innovation is essential for our strategy, and is present since our foundation, is in the DNA of the company. But how Embraer decides what will be developed, what technologies we will develop in the next years. We use the concept of vertical innovation at the company. Verticals are strategic and priority teams in which Embraer focuses its investments and efforts through innovation. So, based in the strategic plan, in the innovation trends, emerging technologies, technology trends in the aeronautic industry, and we defined the verticals that are areas that we will be developing competence and technology in the future years. So now we have the verticals listed here. We have the vertical for zero emissions, for autonomous flights, aircraft competitiveness, AI, data science, industry 4.0, passenger experience, and cybersecurity. These are the main areas that we are developing our competence today. We are developing our innovation products today. Talk about the technological development at Embraer. In our development, we consider the technology readiness level. The technology readiness level is a model originally developed by NASA that's used to measure the maturity level of technology throughout its research, development, and deployment phase progression. TRLs are based on a scale from 1 to 9, with 9 being the most mature technology. TRLs allow engineers to have a consistent datum of reference for understanding technology evolution, regardless of their technical background. Systematic addressing of TRLs is required, allowing technology to evolve from conception through to research, development, and deployment. So we can see in this picture the main objectives of each level of the TRLs, starting with in the TRL 1, when we develop basic research, and then we go to proof of concept in TRL 2 or 3. In the technological development, we are talking about TRL 3 to 6. It's considered that in the technological development, we go to TRL 6 to develop a level of technology that is that will be transferred to another areas of the company in order to proceed with the development of the technology. So in the tier L6, we are talking about the prototypes or demonstrators of the technology. And then the other areas of the company will evolve the technology in order to have the products or service development and the operation, and to design and manufacture the future products of the company. And another important model that we adopted at the technological development is the triple helix model for innovation. The triple helix model was developed in 1997 to explain the dynamics of university-industry-government relations. It states that the relationships between these three actors must be mutually beneficial for a successful innovation system. Each actor has its own role. Government provides funding, industry invests resources and expertise, and academia develops knowledge through research. Together, they form an interconnected web to create ideas, test them out in the real world, then refine them into products or services with commercial value. This allows for more efficient use of resources and encourages innovation to happen faster. So today we have projects based on this concept. So we have projects that will show later to you that we have involvement of the government and universities. And I will show to you how we can use this in practical projects that we are developing today. Now I'll talk about my area. The department that I work today is the Intelligent Systems department. So what is intelligent systems? To talk about intelligent systems, we can talk about the Guadalupe. The Guadalupe was created, modeled by John Boyd. John Boyd is a colonel of the U.S. Air Force that modeled the decision-making process in the military domain. The Guadalupe is divided in 4 components. So we have the observe component that is where we collect information from environment using sensors. Then we go to the orient component when we will process and analyze the information provided the sensors to transform the information in knowledge. Then we go to the decide component when we will generate course of actions hypothesis and you generate an action plan. And finally, we go to the act component when we will employ the means to execute the plans. And the cycle repeats a lot of times in order to have a best understanding of the environment and to create the best hypothesis in the course of action. So the intelligent systems area, we are committed to developing technologies to make it possible to have this cycle performance as better as possible. And as a final product of our development, we have the decision support systems, where we implement solutions for the decision-making process, providing providing good information for the decision making, and to have the best of the best information provided for decision making people in order to have the best actions and the best situation awareness acknowledgement for decision making people. And you can see that our development is not restricted to aerial platforms. We work as well in the development of technology for the Navy and for the Army as well, in developing C2 systems for the decision makers. These are the main areas that we are developing technology today. So here I bring to you a general view about the main disciplines employed in such systems of information systems. The first discipline is data fusion, when we process information from different sources to create a simpler and more robust situational awareness. Then we have the image intelligence, the use of computer vision technique to recognize patterns on videos, the distributed systems that we develop software and hardware technologies to create more robust systems. In case of destruction of parts, the remaining components shall have a consistent information for command and control. This is the importance to have a distributed system, not a central system. The communication discipline is important to make information flow along participants and whole chain of command, the reporters and the others. The modeling and simulation. Since we are dealing with potentially dangerous environments and expensive assets, to simulate these elements is very useful for research and development. And finally, we have AI and data science, where AI complements data science and helps make machines intelligent. It allows machines to recognize patterns in data and solve complex issues. So these are the main areas that we are developing our solutions today. Okay, now I will show you some projects that we developed in the last years and some projects that we are developing right now. The first project that I'd like to comment to you is the distributed data fusion system for naval applications. It's a project that we developed in cooperation with Brazilian Navy and Brazilian Research Institute, IPQM. In this project, we have some sites around the Guanabara Bay. In each site, we have some sensors installed, like radars, cameras, and AIS sensors. And the objective of this project was to increase Embraer readiness on data fusion algorithms using real sensor data in real environment. This system is capable of generating a unified vision of the Guanabara Bay, processing the information provided by different sources in order to have situational awareness, unified situational awareness. So we developed here algorithms for distributed data fusion, processing the data provided by different sensors installed in the different sites. We installed the sensors in different sites in the Guanabara Bay. Sites for belongs to the Navy, and we have besides the fixed sites, we have a truck with some sensors installed. This is the ground unit that can be transported to different places in the Guanabara Bay. And you have a boat as well with these sensors that can move around the Guanabara Bay in order to make the surveillance of a specific area. And in this project, we developed a communication link among the different sites, transferring information from one to another. And in each site, we have all the information available. So in each site, we have the data fusion processed locally in order to have the situational awareness of all the Guanabara. As I said, this was a partnership with Brazilian Navy and counting with Brazilian government funding from FINEP. In order to say about the sensors, we have radars, we have cameras installed in each site, as well as AIS receivers. And we developed algorithms for correlation of the data provided by different sensors in order to have common situational awareness pictures, better estimates for positioning, velocity, and coherent identification among the sites. This is a picture. In this picture, you can see this building that during the project is the Centro de Sobras at PESC-COPPE-UFRJ. And in this building, we have a photography of. We have the possibility to receive from all the sources, all the sites, and here we process this data provided by the different sites in order to achieve the common situational awareness, the common situation picture of the Guanabara Bay. So we have a link here, a radio link between this place and all the other sites around the Guanabara Bay. And in this place, we receive the information generated by the different sensors and process this information here in order to have this unified picture of the Guanabara Bay. We can see here the ground site that I commented before. This truck, we have sensors installed, we have cameras, we have radars, and then we have some antennas as well in order to make the communication among the other sites. At the right, we have the picture of the plot structure. Here we developed the plot structure. We process the data provided by the radars, and we can, after this processing, we can see the tracks, we can see the plots. That means detections of the ships that were detected by the radars in the Guanabara Bay. And here we can see the automatic target identification and the recognition system that we developed in the project, showing the ships that we found in the Guanabara Bay during the collection of the data. So we have this view from one site, but we can provide this same view to in the other sites as well. So in this form, we can cover all the Guanabara Bay area using the cameras and the sensors, radars installed in the different sites of the Guanabara Bay. This is a picture from the screen of the C2 system when we can see the tracks generated by the systems after the fusion. So we received a lot of information from different sources. In these systems, we integrated this information in order to have just one unified picture of this thing, of the Guanabara Bay. We can see the tracks represented by this yellow symbol. So each one represents a ship that is located in the Guanabara Bay in that moment. So it's a very challenging development here, because the process of the fusion, the development of the distributed data fusion is not so easy, because you have to have a unified comprehension of the situation in the Guanabara Bay. So this was very challenging to develop this distributed data fusion algorithms. And here we can see the final results of our work. We published a paper about this work in the Fusion Conference in 2020, showing the results of the summary results of this work. The other project we finalized last year. Now we are developing another project here in Rio de Janeiro, cooperation with Graph, PUC, and funding from Embraer. And in this project, our intention is to develop algorithms for automatic identification using cameras, and to develop algorithms for the tracking of the vessels and the ships in the Guanabara Bay using cameras and AIS data as well. So the main goals of this project is to develop a data curation methodology to build image databases for target recognition and identification applications, demonstrate the automatic target classification and identification in a real-world scenario, develop algorithms for target tracking using information provided by the cameras and the AIS systems, fusing informations of these two sources. The stats today, we are deploying sensor sites in the Guanabara Bay, in some places around the Guanabara Bay, and we are developing a containerized deployment architecture to run microservices responsible for several tasks, for the detection, geolocation, classification, identification, multi-target tracking, data gathering, annotation, and curation. So this is the project that we are developing right now here in Rio de Janeiro. The next project is the multi-sensor image-based navigation. This is a project that we are developing in cooperation with ITA, EAV, SAAB, and the Linköping University. In this project, we are developing image processing and sensor fusion for aerial navigation in a GNSS-denied environment, using inertial data and image-based measurements to estimate the aircraft position, velocity, and orientation. We are evaluating the algorithms and the techniques using both simulated and the real data. So this is another project that you are developing right now. Another project that we are developing in cooperation with ITA, SAAB, and here at the university is the cooperative threat engagement using drone swarms. In this project, we are investigating methods to the development of managed and unmanned teams involving autonomous drone swarm for cooperative aerial engagement. In particular, we are focusing on managed and managed teams of multi-rotor aerial vehicles, and the particular objectives of this project are to develop and analyze high-fidelity dynamic modeling, flight formation control guidance, collision avoidance, distribute the high-level decision-making dynamic resources allocation, and evaluate the interaction between the high-level decision-making methods and the low-level control methods. In order to develop this project, we considered a defense scenario based on the loyal wing concept, when we have two teams, a managed and managed team, and the kamikaze swarm of drones that try to destroy the leading drone on a protected area on the ground. And then the mission of the loyal wingman is to defend both the protected area and the leader against incursions of kamikaze swarm. So here we are developing distributed decision-making algorithms in order to provide the best action and to select the best to make the actions in order to protect the leader or the protected area. This is another project that we are developing currently. Here I have a short video showing some results of this project. I will show to you. Sorry, I have some problem. Sorry for that. So I started the video showing the results of this project. We developed this project first in a simulated environment, and in the next phase of the project, we will go to a real environment. We will have real drones in a laboratory, making these same actions that we are seeing here in the simulation. This is the next phase that we start now, and we believe to have this scenario developed in an arena of drones in next year. We have had PhD students developing the algorithms for the low-level control, and another PhD students developing the algorithms for the distributed decision-making in this phase. We can see that the loyal wingman must to identify the threats and select the best gun to attack and destroy the threats. And the decision-making algorithm shall select the best loyal wingman to be employed in the defense activity. Each loyal has two different guns, or hypothetical guns, in order to use to defend the leader against the incursions of the kamikaze drone. Related to this work, had a paper published in the ICAS conference last year in Sweden, and they published a paper in the IEEE Access journal as well. So that's it. Thank you.
Hello, hello. Thank you, José, for the amazing talk. It's great to be able to bring you here for the second time, actually, but before José was just for meetings, and now he's presenting. It's great. So, questions from the audience to José about his work, or about things he has to do, because we have a lot of things in here talking about autonomous drones, the announcements about on the water, UAV, or UAVs on water, but drones team actually right now have Área founded and been working on those aspects. So it's very interesting talk, very important to us. So questions, things that you want to talk. Okay. 1, 2, 3. Ladies.
Good morning. Thank you. I'd like to ask if the surveillance project, the surveillance from Guanabara project, is ongoing. It's being deployed. It's working.
Yes, thank you for the question. The infrastructure is available, belongs to the Navy today. So the Navy is responsible for the maintenance of the system, and the Navy researchers are using this infrastructure to develop the algorithms and to make another project based on this infrastructure that is operational. Yes.
Oh, because I want to ask about the incident where a recent incident where a ship drifted and collided with Ponte Rio, and I would like to know if this project analyzed the event somehow.
Yes, the infrastructure can be used for this purpose, but to do this, we needed to develop algorithms for intentions or to analyze the trajectory of the ships. For instance, if the ship deviates from the route, the system shall provide an alert to the operator, and the operator must take some action in order to avoid the problem. So it can be used to do this.
Thank you very much.
Thank you.
Okay. Thank you for the nice presentation. I'm Maria Cláudia from Military Institute of Engineering. We are also very interested in what you are presenting. I was especially curious about the Guanabara Bay project also, because I understand that there are data coming from different sources with different representations. So my first question is this: if the really heterogeneous data coming by, and how to gather them and fuse them in a way, if there is a data model behind it. I mean, to integrate the data and then fuse it in a single image. Thank you.
Okay, thank you for the question. Yes, in this project, we integrate different types of sensors. We have different types of radars. Each radar has a different protocol and different data formats provided by the radar. So we had to develop an adapter to translate from one format to another format in order to have a common format in the end. And we making this, it's possible to fuse the data. We needed to put all the data in the same format in order to fuse the data. So we developed these adapters in order to make this transformation of the data, as well as the cameras. We had different protocols provided by the different cameras, so we had to make the adapters as well to have the same protocol on the format at the end in order to make the fusion. I know. Did I answer? Yeah. Yes. Yeah, in this project, we didn't work with high-level fusion. We didn't develop semantic algorithms to process the data. We concentrated on the low-level fusion, but considering the signals provided by the sensors. But it's a good point that we needed to develop in the next project to take into account the semantics of the data as well. Yeah. Okay. Okay. Sure. Okay. Thank you.
Hi, good morning. I think this Guanabara it's a project that is getting attention from a lot of people. We're also working on a project that do this ingestion of AES data, and also we have like integration with the visual information system for a couple of ports, harbors. My question is, you guys do some kind of downsampling, local downsampling of the data, because like for IS, we have multiple antennas, and we have a lot of the same data for the same chip coming from a different place, sometimes with different time steps, sometimes with like low quality the data from some points. How, if you can disclose, like how do you aggregate the data and do the downsampling?
Yeah, so we received a lot of data from the different ships at different moments as well. I'm not so specialized in the processing of this data, but I can say that we needed to filter the data in order to not use the poor data or data delayed in some time. But I'm not so good to answer about the process of the AIS data. One part in this project about the cameras and the AIS is that we have ships that don't provide the AIS. So in this case, we can use the cameras to track the ship. When we have the data, the AIS data provided the ship and the camera data, we can fuse these two information in order to have the track. So we are developing algorithms to fuse tracks provided by the cameras and the tracks provided by the AIS system as well. So specifically to talk about the methods to filter or to processing the AS data, I can't talk to you so much now. Sorry. Okay.
Oh, thank you, José, for your talk. Your time is running low, so thank you very much for your presentation. Thank you very much for coming here
Thank you.
all the way. So thanks a lot. We will go to the next question. There are some questions from YouTube that are provided to you for their analysis.
Okay.
If you want to know a little bit more about the data fusion field in the magazine that you have received, you see a lot of letters, 2-page letters, detailing some of the key areas of research. So high-level fusion that José is talking about, particle-level fusion, sensor-level of the data, high-level data. So you can take a look at the magazine and see the outcome prospects. Also, the magazine is available on PDF on the IZIF website, so you can also I took a lot of pictures for the next keynotes from there. So thank you, José, once again. And this research has been going on for around 7 years. I've been accompanying this project with Guanabara with José year to year. So amazing job. A lot of work. Several sensors, big sensors, and a lot of data in them. So it's congratulations on your work, José.
Thank you very much.
So, guys. So we are starting the next session. So paper 2. Paper session 2. The paper session 2 starts with a little bit